So 7th grade today is a new way to do a thing we have done before. We have before worked on problems like these with variables. Anytime there's a variable and a problem, we talked about doing the opposite of what the problem was doing to figure out what the variable's doing. Today though, I'm going to take you on sort of a different path to get the same answers, and I'm going to make you show some work a certain way. So carefully watch this video and show the work on the homework papers the way that I'm showing the work on my board. I have two things that go with this lesson today. One is just a problem with some notes that are the same problems that are behind me on the board. If you want to practice doing the work showing on this with me, that might serve to benefit you. When you go to do the homework paper, you'll need to show the work the way that I'm showing this on the board. I'm trying to emphasize here a few main ideas to take you on a path to your future, because everything in math has an opposite. And you're going to spend a lot of time from here forward in math working with problems where there's variables, and you're trying to figure out what number can go in for the variable and work. So for a lot of you right now looking at this one, you're probably thinking, I can do that without you. That answer is 5. And I would agree that you could do this one without me, and then its answer is 5. The way we're going to do this together, we're still going to get an answer of 5, but we're going to start to develop a little bit of a method to do this, because someday in Algebra 1, you'll see problems like that. And you're not very quickly going to come up with what number would work in that problem. If I go like that, that just became an Algebra 2 kind of problem. None of you will very quickly come up with what would work in this problem. Someday you'll see a bunch of weird stuff like this. You don't even know what this symbol means, okay, because that's a calculus symbol. And we're trying to develop a mechanism that will work on these easy problems, but will last you through the rest of your math careers. And here's the thing, everything in math has an opposite. Okay? On our board today, everything is either adding or subtracting, and those are the opposites we'll work with today. That weird symbol I drew from calculus on the board, it also has an opposite. You look at somebody's calculator that's an older person and they have all these buttons on there that you don't even know what they are. Those all have opposites. So emphasis points today, one that we've already talked about this year is going to be to do the opposite. Anytime you're trying to figure out what to do about a variable, you're going to do the opposite. But another main point of emphasis for the day is going to be to do the same thing on both sides of the equal sign. And I always make an analogy on this lesson that these problems are called equations, so that'll be the title of the next few papers. An equation is just a problem that has an equal sign in it. But my analogy is that an equation is like a scale. And I don't mean a scale like the scale in your bathroom that you might stand on this morning to weigh yourself, but one of those old-time scales, where if this weighed 7 pounds, some 7-pound item in medieval castle days, they'd have a scale with these two platforms. So if I put my item that I don't know what it weighs on the platform goes clunk. And then I would have to guess what I thought this might weigh by putting a weight on this. So I might guess that's 10. If I put a 10-pound weight over here, the scale would go clunk. And then we know 10 was too heavy. So they might take the 10 off and put a 5 over here on this platform. And then the scale would go clunk, and we know 5's not enough. So maybe you put another pound on here to be 6, put another pound on here to be 7, and once you got the 5, 1, and 1 to make 7, the scale's going to be balanced. If I came along and added another pound over here, to keep that scale balanced and know that's 8 pounds, you'd have to add a pound over there. And if you did the same thing on both sides of the scale all the time, you would keep that scale balanced. Doctor scales are a little bit like that. They have that balancing thing where they move the weights along the scale, and then they have a thing that slides and it balances out when they weigh you right. But that's my analogy today. These equations are like scales. We want to keep them balanced. So I have three main ideas to express that I'll show in the way I do these problems, and I'll want you to show in the homework to develop a thought process that will last you well into the future. So the first main idea, again, is find the variable and do the opposite. Second main idea is whatever you do on one side of the problem, on one side of the equals, you do on the other. The third main idea is that we always want to check our answers to make sure that they work by putting them into the problem and just seeing if they go. So here's the kind of thing I'm looking for you to write. Again, we're already in agreement that this answer will be 5. 5 plus 2 is 7. Okay, but what I'm going to want you to show me to develop these thoughts that will last you well is see that the problem's adding 2 and do the opposite, which is subtract 2. I'm going to write 1 subtract 2 right underneath the add 2. Then I need to cross the line where the equals is, and on the other side of the equals, put another minus 2 to keep this balanced. Whatever I did on the one side, I have to do on the other. Here, if I'm going to add 2 and subtract 2 in the same area, those just eliminate each other. If I gave you 2 of something and then took it right back, that just sort of eliminates itself back to where we started. And that's what our goal is in doing these problems, is to end up with a variable who is alone. I'm going to draw a line here to put my answer. So the only thing that's left that I didn't cross out is an x. The equal sign is still there. And I'm just going to do math. 7 minus 2 is 5. And I already did check that earlier because 5 plus 2 was 7. I'm looking to see all of this kind of stuff. Either an add or subtract symbol on both sides, a number on both sides, with one grouping where the pair of numbers got eliminated by us crossing them out, an x, an equals, and then some new number that we came up with that is our solution. I don't care on the homework if you copy anything into these blanks. If you can fit this work and the answer in that little space that I gave you, feel free to do that. So for this one, I find the variable, I see it subtracting 3. So I have to do the opposite. I'm going to add 3 underneath the 3's where this can eliminate. Subtracting 3 and adding 3 is just an elimination. And then I'm going to add 3 on the other side of the equals. I'm never going to put anything under the x for today. The x is always just going straight copied into the solution line. The equals is always just going to be there still. And then do math. 4 plus 3 is 7. And to be sure that worked, try it out. 7 minus 3 is 4. So you could put a little check mark for me when you check it. So I'd be looking again to see an add or subtract symbol with the same number, one on the left and one on the right. A pairing that got crossed out. Bring the x down under the solution line, bring an equals under the solution line, and then a little bit of math. And the last little step is to check it. Here I put the variable on the right, but that doesn't do anything for us really other than we have to pay attention. The variable is adding 3, so I'm going to do a subtract 3 to eliminate all that 3. And then here underneath the 9, I'm going to subtract 3. 9 minus 3 is 6. Leave the equals in there, leave the x in there, and then let's check it. 6 plus 3 is 9, so check. If you think you have the hang of this, pause the video and try it like 3 of them in a column. And then unpause it and see if you did what I did and wrote what I wrote. For this one, I see a subtract 2, so I'll add 2's. 2's are gone. X remains, equals remains. 6 is created. 6 minus 2 is 4. I did check that and it worked. Adding 3 makes me subtract 3's to eliminate 3's. Leaves me always an x and an equals. Every answer under the solution line will have an x and an equals. Negative 8 minus 3, you have to be careful you go to negative 11. If that's causing you trouble, maybe rewatch the subtract video. That's a negative minus a positive, that got us a bigger negative. To check it, we're doing negative 11 adding 3. When we add a negative and a positive, it depends on the bigger, which is negative. We subtract, that is 8. If that caused you trouble, you might want to rewatch the adding video. But those rules are still being used on these. All those negative positive rules are still around this week. Here, adding 4 makes me subtract 4's. Those 4s eliminate, because there's with adding and subtracting. These don't eliminate. -4 subtracting another 4 leaves you down to -8. The x is still there, always copy the x. Checking it out, -8 adding 4 is -4. That's that same rule for adding, depending on which was bigger, and we subtracted. If you're getting that, again, pause, try another column, see if you do what I do and write what I write. Add 5 makes you subtract 5s, eliminating 5s. X would equal -3. -3 adding 5 is 2, so that checks. Adding 4 makes us subtract 4s. I'm never writing anything under the x. I'm copying the equals, I'm copying the x. The 4s eliminate. -3 minus 4 is -7. And if I check it, -7 adding 4 is -3, that did work. Subtracting 6 makes me add 6 to eliminate 6s. Copy x and equals, as always. Adding 1 of each, that gets me a +4. Positive because positive is bigger, 4 because I subtracted. If I check it, 4 minus 6 is -2, and that checks. This I see is subtract 7, so add 7s to eliminate 7s. X would equal a -3 if we do that same adding rule, but dependent on the bigger one. Checking it, -3 minus 7 is -10. Here I'd add 4s. Eliminates those. It also eliminates those. On this, after the equals, you get a 0 because those wiped out. So x equals 0. Checking it, 0 minus 4 is -4. Subtract 8, make me add 8 to eliminate 8s. X is alone now. Adding with the different signs again, it's that same rule. It depends on the bigger one. We subtract them. It is a 2. Checking it, put the 2 where the variable was. 2 minus 8 is -6. That does check. It seems on the video right now like checking is pointless. Checking is pointless today while you're working with me because I'm not going to miss any. But when you do your paper on your own, anytime you would make a mistake, checking would catch your mistake. And you're going to make more mistakes than I am because I've just been doing this a lot longer than you have. For this, I put things again a little bit out of order, but that doesn't matter. Okay? Again, we're adding a 3. Find the variable and see that it's adding a 3. So subtract the 3 to eliminate. Subtract the 3 over there to keep our balance. Copy the x and the equals. 10 minus 3 is 7. Checking it, put the 7 where the variable was. 3 plus 7 is 10, so that does indeed check. If they're adding 6, I'll subtract 6 to eliminate 6s. Variable alone is always the thing to celebrate. That'll be the goal of a lot of the next few years of math. Have a variable, get it alone. The variable is going to equal -4. If I do 2 minus 6, that has to be negative, because positive minus positive is only a positive if the first one's bigger. If that subtracting is messing you up, there's a whole subtracting video that can recap that skill. Checking it out, 6 adding that -4. Adding rule for the depends on the bigger one again. That does get us 2, that does check. This variable is adding 1, so I'll subtract 1 to eliminate 1s, and that gets my variable alone. And over here I need to subtract 1 to keep our balance, and that gets a 3. Checking it, 1 plus 3 is 4, so that does work. And the last one for today, this is adding 9, so I'll subtract 9s to eliminate 9s and get the variable all alone. 5 minus 9 is -4, and if I do 9 plus -4, that does check, that does make 5. So that's today. Again, work emphasis is make sure you're showing me whether you're adding or subtracting. Those last few were subtracting, here's one that's adding. Make sure you cross out one pair of numbers on the variable side so that the variable's always alone, has an equals, do some math, and then always look to check your answer. But everything that I wrote, you should write. Okay, all the cross outs, all the -9s, all the +3s, all that stuff, every check mark. The way mine looks, that's how yours should look. Today's all adding and subtracting. Tomorrow, same main ideas, but we're going to multiply or divide. So, hope that does well for you. If you have questions, send me an email, we'll talk on Zoom or some other way.